Hi. And okay, so it's it is I think it's Bhagavad Gita. I follow Bhagavad Gita, and they are conducting a Bhagavad Gita part outside of my house, like very near here. It's here only, so it's very close. I believe you can hear that. Okay, so this is day two of me doing HFT preparation. High frequency trading companies like Graviton and okay, I love Graviton, so I only remember the name of Graviton. Okay, so right, so let's start. Okay, I actually recorded part one of this video. Okay, so a few of the ground rules first. Uh, I will be just doing. Okay, let me. I have this mic. I bought it from Amazon. It was on a review, so I bought it. So like, I got it for cheap. So I bought it, and I wanted I have a lot of apparatus. I have a lot of stuff. I have a phone that has a good recording, and I have this tablet that I write my code on. Uh, it's a Motorola tablet. I bought it from my own internship money, and I have this. Okay, so uh, a few ground rules. Like I'm preparing for HFT preparations, and so this is the stand, so I can keep my hand here. I'm doing 90 days. I'm taking a 90 days challenge to get into top HFTs like Jane Street or Jane Street. I don't know. So like very big HFT companies, and I will not focus on content creation, but I will be like creating the videos for my own discipline and to talk like talk out the, what do we say, code and explanation, so that I become good at interviews, right? Because that is the end goal of every preparation everyone does. Okay, so a few ground rules. I have a lot of video creation stuff that I will not be using. I will just record the video and upload it on YouTube. No editing, nothing. I will do like anything extraordinary or something like that. So this is my Linux Fedora system, right? I would love to show you. Oh, there's a oh my ZSH update. Yeah, sure, go ahead. Yeah, it's okay. So I've been using Fedora for like a very long time. I'll just show you my system configuration. So it's a Fedora Linux 43 workstation edition, right? And I believe it's the latest Linux 6.18.8. 200 is the status code, I believe. Yeah. And ZSS 5.9. Hyperland is the, yeah, I am using Hyperland in Fedora because, yeah, I like it, yeah. And I have a Asus TUF gaming laptop, but I never used it for gaming, so I'm pretty sure the thermal paste is very very good on this laptop right now. So yeah, so it's a gaming laptop, and it has an i5, and it's a GeForce 3050. There are two screens. Okay, so this one is my laptop. This I'm pointing here. So this is my laptop, and it has a built-in webcam I can use. I have a better mobile. I have a better mobile, but I will not be using because it requires setup, and I don't. I want to be an engineer that gets placed, that gets a job at HFT, not content creator, right? So that is that. I want to be an engineer, not a content creator. So, and the next monitor I have is this, is here, right, where you can see my mouse, and the photo here is Sri Bhagwan, right? And actually they said Bolye Govind Bhagwan ki jai. So this is Shri Krishna. In this picture, I believe he has held the Govardhan Parvat on his little finger, the tiniest finger, and that is the depiction this picture has. And we worship Krishna also, and the Govardhan Parvat also. So it's a, and we also worship the cow. Uh, I believe cows cannot. My face is not able to. Let me see. Yeah, here's the cow. We worship cows also. Okay, so yeah, and this is my room. This is my room. Right, there's a small fan. There's a small fan there. There's a fan. One more fan above me. Right. I have a guitar that I rarely, occasionally play it, right? And I like to be organized, so uh, my warm blanket and that mosquito net, and over there is my pillow. So, and there's a window that I keep curtain closed because it is February 7, right? February 7 today, and yeah, so that's basically everything. Uh, and here's my system. So let's just close this. Yeah, get closed. Okay, so I am posting this video as a day 2 of 90-day preparation for HFTs, right? And let's I will post what I have done on yesterday. So like what all stuff I did as part of sorry, as part of preparing for the uh, these interviews. Also, the main character, the rubber ducky approach I follow with this guy. His name is Mr. Pengu. So Mr. Pengu is my interviewer for most of the time. He asks me questions and helps me when I get stuck. So say hello to Mr. Pengu, and I keep him here, very close to my laptop. Right, stay there. Okay. Also, one last thing I keep at my table is this Srimad Bhagavad Gita. Hare Krishna. Okay, so and a glass of water if I need it. It's half empty because I drank it. And there's also a small LCD tablet I keep. So I usually at the start of the day I usually uh, put my tasks on this, and then go ahead and keep it on my monitor so that I can track my tasks. Okay, let's start then. I will go over to Google Chrome. Yeah, come here, bro. Okay, it is asking for an authentication keyring, and yes, I have a mechanical keyboard. So yeah, let's just not restore pages. Uh, what all I did was I believe I did it in Sublime Text. Yeah. Okay, so for yesterday I created a struct market order, and I am getting used to this including all the header files that I need explicitly, right? Instead of doing this, so you can just go over and call the bits standard c plus plus dot h, which imports all the library to the current environment, the current file. But for an HFT mindset, I'm learning that. So I'm using AI Studio and ChatGPT to guide me through the process. So they explicitly said that I should not do that. I should is the screen too white? Okay, the screen's good. So they said to not do it, and instead you should import the headers by name. Then if you want to use C in and C out standard input operations, so you can go ahead and bring IO stream inside. And also using namespace standard is also not a good what do we say, not a good practice in HFTs. So you should not do that. Instead you should just like go ahead and do standard C out. And this mic causes a lot of issues with me and keyboard, bro. Yeah, that's background noise coming. You have to keep it. So I have to get this update. So I decided not to wait and just go ahead with the background noise. I hope my voice is audible enough. I'll just keep it close to my mouth, right? I'll just save it and I'll just build it. Okay, so this already has a build system. I have already done this C++14. I have created it by hand, so I don't think it will show me that build system. Yeah, okay. I have created it by hand, so yeah. Okay, so in this market order struct, I actually wanted to. Okay, so I commented out this using namespace standard. I don't need it anymore because we just followed what the user structure should look like in a production environment in an HFT or something like that, or in a very high performance system. Okay, so standard cout will just print the original size, and we are using the size of function and passing the struct in this function, right? And we are just adding the bytes as and this is also performance thing, that instead of clearing out the buffer with end line endl, I can use this, but I believe that it clears the buffer. So in competitive programming, you usually use \n with the quote on quotes, double quotes, right? And so yeah, I believe I actually don't know whether the production environments in high frequency trading companies or big tech companies for like Fang and something. Okay, so my favorite companies to work for are like Google and Graviton. Both start with G, right? Okay, in Google I would love to work as SD1 and like yeah. So and at Graviton I would like to get a job as software developer 1. I mean the fresher roles, you know. So at also the most lovable company I believe is Tower Research. So I would love to get in any of the company, but these are my top preferences. If I get an offer from Uber, I would be stupid not to go there. So I would absolutely not reject that offer and go with them with closed eyes. But if I had a counter offer, then let's not talk about future. And I will just clear out the buffer. So save and build. And there's an error. What does the error say? Standard endl was not declared in the scope. Oh, okay. So yeah. So we removed the std. So we have to do this standard and then build. So it says original byte 60. Okay. So in this struct, right? If I go over here and right, let's do this. Okay. The character is 1 byte and the boolean data type is 1 byte. So we should we should see here 2 bytes, right? Let's save and build. We see 2 bytes. That's like very easy. What if I create an integer named like anything? So what did I create with the names? Yeah, int quantity and double price. So what if I just go over here and comment it out, right? And we'll just save, and I believe the output will be 1 plus 1, that is 2, 2 plus 4. So 6 bytes should be the answer, but I am not sure about that. So let's go and build this. It's 8 bytes. Because this is what I learned yesterday. So what happens is that okay, the compiler does something. It's like it takes up it rounds off the, so it takes up a memory position, right? A memory position there. It is a multiple of 8, right? So it is something like the what, how do I explain? Okay, I'll just write it out. So there's a memory address where the address is something like 16, right? So it's an address which starts with, oh my god, but so it starts with the 16, right? And what did the struct says? It does is what it creates a struct which has the memory address located at okay, uh, okay. What happens is ki I'll take a Vivaldi nahi bhai, not Vivaldi bro, come on. It's like I would like to explain a bit कि भाई कैसे चीज़ें चलती हैं. अरे ये सब क्या क्या आ रहा है. तो जनरली क्या होता है कि एक ऐसा वो होता है, इट्स लाइक it's like that, and then this is here. Let's go. So okay, there's 0, 1, 2, 3, 4, 5, 6, 7, and 8. So this is a general how memory looks underneath in the CPU. So I'll just create this. I believe my drawing is very weird, right? Okay, so we'll consider from here to here. What happens is okay, so we'll just comment out this also. So when we run this char and bool, so they can take up any position. So if the struct wants to, it's a 2 bytes, so it can take this position, it can take this position, right? It can take first position, it can take this position. They can sit at any position they like. So there's no issue with that, right? And I'll just use, so they can take this position, right? So struct takes this position, and this is available for memory, and this is also available for memory, right? So there's no issue with that in one and one bytes, right? Okay. When we add int, right? So it's 4 bytes. So 4 plus 1 of this, it becomes 5 bytes, and then this 6 bytes. So what our CPU does is adds a little bit of 2 bytes padding. So what it does is it adds a padding. So let's assume our struct took this much part of the code, right? Okay. This much byte. So but for the next one to be aligned, we want it to be aligned. So okay, so by my mistake I just made 7 boxes, right? So let's assume our struct takes this much position. Okay, it's cool. But what we have to do is these 2 boxes remain. So I I'm not very sure with that, but I will just assume that what the CPU does is adds these two also to the struct, and at the end of the day, we are left with this much as our struct. So it's cool, but because we are using what we are using. We use a bitwise system. I have a 64-bit system. So okay, 8 ones are 8, 8 twos are 16, right? 16 twice becomes 32, 32 twice becomes 64. So we have to think in that manner, right? If it is not 4, like if I remove both of these, right, then I'm pretty sure the size here will come out to be 4 bytes, right? I will just go over here and show this to you. Okay, save and build. Let's look at the position. It says 8 bytes because it is cached. It will say 4 bytes. See, it's 4 bytes, right? Okay, I have to save build. It's 4 bytes because we have to follow the two bitwise system, 0 1 0 1 0 1, right? If I add these, then it will not show 6 byte, it will show 8 bytes, because if it is more than 4, if it is more than 4, then it will probably, okay, even if I remove this also now, it becomes 5 bytes, but it will show up as 8 bytes, right? Save and build. Now I get it. 100%. We have to follow the 8-based architecture thing, because we are on a 64-bit. I am personally on a 64-bit system. I think majority of the systems are now 64-bit systems, right? Even if they are not, the 32-bit systems, I believe it is day 2. I believe they would use the 8-byte indexing or something like that. So let's just include the char and everything we have, right? Double price and this stuff like that. Okay, everything's good here, right? So 1 plus 1 is 6 plus 4 10, 10 plus no 4, right? 4 5 6 6 plus 8, it should be 14 bytes. Okay, it should be 14 bytes. 14. So I believe now it will be 14 bytes, right? That's not relevant, bro. Come on. Okay. Control and save and build. It's 16 bytes because 14 bytes cannot. Is not a multiple of 8. (14) is not a multiple of 8. 16 is, so that's why. Okay, if we do this, right? Control Shift Z, Control X, right? If we do this, right, it should come out to be 14 bytes, right? But it doesn't, because the first space is occupied by the first space will be occupied by right, the first space is occupied by the char, right? And then the bool will occupy the first space. Now what happens? It's stupid. It's really stupid. Then double comes up. It's like 8, bro. I need to have start from 8. So this much. Okay, so this much I believe remains like that only. And then from here, what the start? The it starts, double starts from here. So double, right? So it adds how much? 1 2 3 4 5 and 6. So it adds 6 here. So let's just calculate it real time. So it was 2 bytes plus 6 bytes got added, right? Okay, cool. And then what happens? Then an 8 byte will get added. 8, okay, right? So it goes over to like so it goes to 10, 11, 12, 13, 14, right, 15 and 16, because it has to align to the C++, the CPU architecture. Again, I am not very sure with that, so just cope with me, right? It's just day 2, I have to go ahead with that. So I believe double will come up till here, and then after this what will happen? That's 17 and 18, right, and 19. Again, this looks again so weird. 1 2 3 4 5 6 7 8, right, and then 4 will take up this. Again, we have to follow that architecture, so it becomes 19. So let's 4 and next 4, right? How much it becomes? It is 4 plus this is 10, right, and this plus this is 20 plus again it becomes a 4, because we have to take that integer also. So it will become 24 bytes, right? And let's just save and build. It will come out to be 24 bytes, because we already have a double. Then we have to align it to that. After this 19, 20 will come, and 21 will come, 22. Then up till here it needs to be aligned because of that double aligning with the 8. So that is how I understood the struct, and how as in how I would love to optimize this. We can just keep the highest space occupying ones at the front, right, and it will just come out to be 16. So what happened is now, right, so 24 bytes minus 16, actual byte size was 14. No, 16, because we did just bytes, which will come out to be 16, 4 and 4. So we just saved 8 bytes of storage in RAM or like anywhere. So that's just a lot of savings. It is very small savings in there, but in high performance systems it's like a lot of it's a huge number. So something along the lines of I'll just go ahead and find out the number. What was it? Okay, 8 bytes saving, right? It becomes 8 bytes saving becomes 80 bytes of memory and potentially millions of CPU cache misses, right? And we just reduced the memory footprint of single order by 33%. It's a saving of 33%, and that's a huge saving in HFT terms. And so that is what I wanted to say. Okay, and for the further updates, I just did the LeetCode problems and go over to I just solved. Which one I solved? I believe search insert position was done. So in search insert position, I was like it was easy. It was just for I know C++ STL function lower bound returns. It returns lower bound of that if it does not exist. So what this question wants is that we are given an sorted array of distinct integers. We are promised that the integers are distinct and it has a target value which we get from here. Okay, so we want to return the index if the target is found, and if it is not found, then we should return that index where the target would get added. So like in this case, okay, so this array is here. Okay, the target is 5, right? So 0 1 2, we found it at the position 2, so we get the output but what if the target is not there? So let's go over. So this is the position. So 0 1, but what happens is 2 should come here between this, so it will take up 0 1 1th position. So first position, so output is 1. So lower bound does what? It goes over 2. It says basically that, hey, I will return the value which is less than or equal to no, the value where it will return the value where nums, right, mid would be greater than equal to target. So that is what lower bound returns. It will check if that I don't think it is specified. Okay, so it will go over to this position, and is if it is greater than target or equal to, yes, it is greater than the target, so it will return this position. Is it greater than equal to target? Yes, it is. So that will. So what lower bound from C++ STL library will do this? It will just return an this part will return an iterator, right? And nums.begin also returns an iterator. So iterator minus iterator becomes an integer, and we just have to return it. So it's a very easy code, but again, we can also do a binary search, and the binary search is pretty easy. We'll just take an answer which is return the index where it would be found. So we'll just take an answer and we'll take int low, which is at the position 0, and high, right, which is at the position nums, and nums dot size, cool, and -1, and we have to initialize the answer with nums dot size. We'll go with the pretty standard format of less than equal to high, right? And we'll just check if first we have to calculate a midpoint with low plus high minus low, and divide by 2. Okay, why did I do this? Low plus high minus low by 2. I could have just written low plus high divided by 2. For integer, the overflow values are something like 10 to the 2 into 10 to the power 7. So what if in any case, if it goes to int max plus int max, then it will just become a negative number and lead to an overflow case. So to avoid overflow cases, I did low plus high minus low by 2, which is exactly equal to low plus high divided by 2, but it avoids the overflow cases, right? Okay, we'll just check not f. So we have nums at the position mid, which is greater than equal to, right? It has to be greater than or equal to the target value, cool. And if it is that, then answer will take up the value of mid, and we have to go behind. So high will become mid minus 1, right? Okay, and if it does not, then we have to go to the position of mid plus 1th element, right? So left becomes, I'm pretty sure it can get mixed up, that logic, right? And we'll just go ahead and return the answer. Let's see if it works. Compiler error. What does it say? iOS space is not assignable. Else left is equals to mid plus 1. Oh, okay, there's no left. Lol. So low is this. Okay, it works. Wow. Let's submit again, and let's see if it is. Yeah, okay. So that was pretty much what the code was, and I only did this as the day 2 part. So it was kind of very, very easy, I would say. And if we go over to previous question, I also tried this. So it's a big question, and I have already done. So what this question says is that we are given an integer. We're given an array of integer nums which is sorted in decreasing order, which is ascending order. Basically, we have to find the starting and ending position of a given target value, right? We have to okay. Oh, cool. So, and if the target does not exist, right, so we have to return -1 cool. And we have to write O log n, so everybody knows it's binary search. Cool. So in this array, right, 0, 1, 2, 3, 4 and 5. So first binary search here, right? I have already written code. I'm just doing a recap or day 2 post. So we get a first which is at the position -1. It will not get updated, right? Only if there's a valid case like here. And second -1. So we get a left, right, nums.size -1. The first binary search loop would previous questions time complexity was O log n. Everybody knows that. And the lower bound function will also use O log n. That is what I know, right? It can take a longer route, but the worst time complexity would be O log n. And here also the worst time complexity comes to be 2 O log n, twice, because we are doing the O log n twice, and space complexity of both of them is O1, constant space. Cool. Okay, so here we'll calculate a mid again using the overflow formula, and we'll do so this is the lower bound function. If you can see, if nums at the position is greater than the we are sitting at the target, and it is greater than or equal to target, then okay, it's cool, we are right, okay, no problems. But what will happens then? If nums mid is exactly equal to target, then only the first will get updated, or the right will come to we'll shrink the search space by mid -1. So mid we have to, because it does not come into the target. Okay, because it does come into the target, we have to go to the left hand side of the part, or we can just increase the left to mid +1, right? And then again, these are the early return conditions. If first equals to -1, then we know that there is no target, right? Because binary search, this will return the first element, so it will return here, so it will return 3 here. Okay, cool. We have to again initialize these numbers, because these will get, so here left will be at the position 3 or something like that. So we have to reinitialize them again while left, and this is the other loop. So here we can also do what do we say, if I want to do it will this work? This is the lower bound function, right? So it will not work, obviously. So less than equal to, and I did this, and it will return the second element. It was just go ahead, and we can just run it and submit it. I have already submitted it, but I'm just doing for the sake of day 2 progress. Right, okay. So that was pretty much it, what I learned in the day 2. And it's okay, so that's all. Okay, bye. Peace out. Jai Shri Ram. I will just stop recording and okay, bye.